Hello, guys. Welcome to the Keto Pro podcast with myself, Richard Smith. Today, I am joined with Professor Seyfried. Professor Seyfried is a professor of biology, genetics, and biochemistry at Boston College, and in my opinion, one of, if not the world leading expert in metabolic cancer treatment and prevention, or even cancer treatment and prevention in general. Professor Seyfried, welcome on board.
Oh, thank you, Richard. It's nice to be here today.
Fantastic. And thank you. This is an incredible treat for me. To get you on has made my day. I know we had to postpone this because you're such a busy man. So yeah, this is a super exciting one for me. So let's get straight into it. Cancer. So through my journey as a nutritionist, I've worked previously with many people who suffer with many conditions. And what I have found is that within the nutritional medical community, there are experts in various fields, i.e. heart professionals, people who work on the brain, kidney, so on and so forth. Now, what I feel that I've learned over the years is that many of these things, if not all of them, come back to diet and lifestyle. Yet we are told that they are genetic. And this is a common theme with the clients that I work with. It's in my genes. It runs in my family. Cancer being one of them. You know, we believe that this is a genetic condition. Could you explain your position on whether you believe that this is actually genetic or something else?
Well, it's not what I believe. It's what the scientific data tell us. We don't believe unless we see data. So we have to look at the data. So you're absolutely correct. The world top cancer research centers, hospitals, government funding agencies say that cancer is a genetic disease. If you go onto the National Cancer Institute of the United States and ask what is cancer, it clearly says cancer is a genetic disease caused by mutations in DNA of the nucleus. And this is what we refer to as the somatic mutation theory of cancer, which has been the dogma, the silent assumption that has driven research and treatments worldwide. But it's people accept it because of confirmation bias, assimilation bias. It's not if anyone with a rational capability of looking at information were to look carefully at the evidence supporting the somatic mutation theory, you would have to scratch your head and say, how is anybody capable of believing this? Let me give you some factual examples. There are papers published showing that there are some cancers where they can't find any mutations. There are no mutations. And if the somatic, if they say cancer is due to somatic mutations in the DNA of the nucleus of some of these tumors, and you can't find any mutations, yet the tumor is raging out of control, then there's something's not right with the theory. And then, after they realize that there's thousands and thousands of mutations in all different cells of cancers, colon, breast, they're all different from each other. Every cell within a person's tumor, if to be analyzed completely, would find different kinds of mutations in each of the cells. So there's no two cells that would have the exact pattern of mutations that another cell would have. But then they break it down. If you go to the National Cancer Institute top cancer journals, they say, well, not all mutations are leading to dysregulated cell growth, which is the definition of cancer: cell division out of control, dysregulated cell growth. We call them now only certain kinds of cancers caused by certain kinds of mutations, and these are called driver mutations. So we have passenger mutations that seem to be mutated, but they don't code for anything. But then we have these important driver mutations, which are the ones that are supposed to be responsible for the dysregulated cell growth. However, new experiments are coming out all the time, remarkably showing that, like a young guy like you, many people, if you take your tissue and look, you find dozens and thousands of driver mutations in tissue that never forms cancer. Well, this is completely against the theory, because you're supposed to have tumors in cells that have these driver mutations and normal people don't. And I think the nail in the coffin for the whole gene theory of cancer was the mitochondrial nuclear transfer experiments, where you can take the nucleus of a tumor cell full of mutations and drop it into a healthy cytoplasm, and you don't get dysregulated growth. Whereas if you take the normal nucleus and put it into a tumor cytoplasm, you get dysregulated cell growth. This clearly says it's the mitochondria in the cell, not the mutations in the nucleus. Now, as I said, if you are capable of looking at numbers and data, and you are somewhat scientifically literate, then this information should be clear to even people with minimal levels of education. Yet, how is it possible that the leading scientists throughout the world are locked into this cancer as a genetic disease when the data clearly tell us it absolutely can't be? So this is the great conundrum that we are facing worldwide, because the therapies that we're developing to treat cancer patients in the clinic is based on an incorrect theory. And as the result of that, in the United States, we have 1,700 people a day dying from cancer, which comes to about 70 people per hour. So clearly, whatever we're doing is not working in dropping the death rate. And that's due to the fact that cancer is not a genetic disease. It's a mitochondrial metabolic disease driven by glucose and glutamine and having an inability to burn fatty acids or ketones. So we now know how to manage it without toxicity. But unfortunately, what I just told you is completely unknown, completely incomprehensible. I can't figure it out. So whatever is happening, we just have to continue to wade through dead people before somebody wakes up and realizes what's going on.
Yeah, which is super frustrating. It's as a nutritionist, I work with doctors and medical professionals within the NHS, people who are open to the idea that nutrition has a big impact on these things, but they are few and far between. But these people are out there, so I present regularly to these communities, and what baffles me is something so simple seems to be lost in translation, and it's almost what they are taught from the outset is incorrect. And as you say, it's a case of being taught the wrong thing, and everyone else is telling you that these things are genetic, and this is what you're taught in medical school, and then to try to think outside the box almost seems impossible. But for me, a layperson,
yeah, well, it's also very hard because your government, well, the UK government, the United States government, the German governments, they award large grants, research grants to scientists to hunt for genes and look at genetic problems. The pharmaceutical companies spend billions and billions of dollars on these therapies to work. So the issue is that, why should I consider cancer as a mitochondrial metabolic disease when I get so much money to say that it's a genetic disease? If I say it's a metabolic disease, I might lose my grants, and therefore I'm going to go hungry. So it's better, as it says, it's difficult to convince. Upton Sinclair said it's difficult to convince someone of something when their salary depends on them not being convinced. So you have a lot of power structure that has nothing to do with the science supporting this incorrect theory on cancer. And unfortunately, we're paying a terrible, terrible price for this. But it's worldwide, which is really remarkable. It's amazing how all the major industrial countries, cities, cancer research foundations are all walking to the same wrong drum. It's like, I don't know what it is, like the Pied Piper of the brain. And you talk to people and, oh, it can't be. They tell me what you just said can't be. I said, why don't you look at the data? You tell me what number is wrong with these. Nobody looks at the data, the data that I just described to you. And as a matter of fact, when you read the top papers in Science and Nature and Cell, they still struggle trying to figure out why these gene mutations that are supposed to cause cancer are not causing cancer. And they never consider, maybe their theory is wrong. They never stop and think, maybe the theory under which we're studying this disease is incorrect. Well, God forbid, because that'll change the whole system, and people are going to have to come to realize this is a very different kind of a disorder than what it was made out to be.
Yeah, for sure. Look, a few things there. I mean, you mentioned there death rates in the US. Did you say around 1,700 per day?
Yeah,
which is an awful lot.
it comes to about almost 612,000 per year. And those numbers come from the American Cancer Society. So what I do is I simply divide it by 365, and you get almost 1,700 people a day. And then if you divide that by 24 hours in a day, it comes out to about 70 people per hour in this United States. Now, of course, in China, it's even far greater because they have a much larger population.
And get into that. The UK currently is around a little bit less, around 460 each day, but our population pro rata is lower. So if we were to pro rata those figures up to the US population, quick calcs, it'd come out around 2,300. Now, I wonder why this is. You know, it's part of me thinks that is it because and we'll get on to maybe treatments and preventions. But a big part of this, I believe, and I'm sure you will attest to this also, is the reduction of carbohydrates, particularly glucose, and introducing and implementing a ketogenic-based lifestyle, which seems to predominate within the US over many other locations in the world. I mean, this is quite new to the UK, the ketogenic way of living, the ketogenic lifestyle. It's new and it's feared as a fad, but I get the impression that it does predominate, and it's a lot further down its journey than in the UK. So do you think that could be a contributor in regards to why the US pro rata is slightly less currently at those figures?
Yeah, I can't speak to that, but I know what you're saying about this. So you know, basically, when you say diet and lifestyle and this kind of thing, you have to realize that as a species, we're about 1.5 million years. We as a species have existed, and most of that time was in this Paleolithic form of existence. Hundreds of thousands of years. Our physiology is that of a Paleolithic man. We would use tremendous amounts of energy to get food, whether we were hunting for it or gathering it or whatever. But it's not easy to chase down a large animal and kill it, and then chop it up and eat it, even if you're firing it. You know, there's no very little, if any, carbohydrates in this kind of beast that we would kill. We would eat the marrow. That was another. A nice story came out of Israel a few months ago, looking at how these large animals went extinct, like woolly mammoths and some of these other kinds of things. Our species, our early ancestors, would kill big buffaloes and all kinds of things, but we would kill the strongest members of the herd, not the weak and the old, the young and the old. We would go for the strongest members. This is a nice study by Israel, by the group, and that because the amount of nutrition that you get in the marrow from a member of the top strongest members of the herd give you more energy. So we knew that you got to kill the top dog and get the energy from him. And what happened then is that the herd was then left with very young and old, which then became bait for predators, because the strong guys that would protect the herd were killed and eaten by us, and now the rest of the herd. So they attributed man to the underlying extinctions of large groups of animals that existed on the planet. So we were very smart at that time, but we had no carbohydrates in our diet. Primitive man did not die from cancer any more than members in Aboriginal tribes that have been evaluated before Western diet and lifestyle came in, like Inuits and Africans from Albert Schweitzer and others. Cancer did not exist in folks that lived according to traditional ways, extremely rare. So that was the Paleolithic man who was always in nutritional ketosis. Not that they wanted to be, but they had to be. They had no choice. There wasn't donut shops and delicatessens on every corner. So you lived in this nutritional state of ketosis. So when you talk about ketogenic diets, all you're doing is bringing man back to a state of Paleolithic existence. Now listen, Paleolithic man died predominantly from infections and injuries because we didn't have antibiotics and we didn't have orthopedic surgeons to fix broken bones and hips. So we would die earlier because we were not able to correct these injuries. What's killing us today are all these chronic diseases that are coming about as the result of our diets and lifestyle. Don't forget, we evolved over tens of thousands of years to want sweet. We want sweet. We would go after honey. We would go after anything that was sweet. So we are geared to want sweet. The problem is now we have an abundance of it everywhere, and we're paying a health price in a different way. So the obesity epidemic, people who are obese are the ancestors of are the descendants of our ancestors that knew how to store massive amounts of energy quickly. Now we have so much energy, we get obesity, chronic diseases, cancer, dementia, diabetes, cardiovascular disease. It's all related to diet, a shift, because as I told many people on these podcasts, we are still Paleolithic man in a modern environment. Our technology, food science and technology, has evolved so much faster than our biology. So that puts us at risk now for all different diseases that our ancestors never had. So it's very easy if you understand evolutionary biology. All of the problems that we have with respect to healthcare is very explainable.
Yeah, I agree. And I think you can probably go even further back to Australopithecus. I mean, we can see for as long back through nitrogen isotope testing, after 3.4 million years, that we've consumed predominantly animal proteins over. Yes, we would have consumed things like berries and fruit, potentially honey and things, but these would have been seasonal. So as a percentage of the amount of carbohydrate we would have consumed in our lifetime or throughout the year, it would have been pretty small. So as you say, ketosis is our natural metabolic state. It's the metabolic state we're born in. It's the metabolic state that we've evolved in almost our entire existence. And the introduction of these toxic compounds, as you say, I believe is fueling cancer and insulin resistance and everything else, because they are all connected. What I'd like to get into quickly, and it's funny actually, you've mentioned, I made some notes when you mentioned about, so I've been looking on Frontiers and some of your papers that you've produced, and cancer as a mitochondrial metabolic disease being one of them. And on there, you've mentioned about the frog and the mouse studies, where we look at the medulloma blastoma experiments. Sorry, with investigators found that the nuclei of the mice, and you've just mentioned this in regards to the melanoma cells, could produce normal appearing, blastocytes. That's got to be proof positive, surely, that if it was genetic, then this would predominate through these experiments. I find that incredibly interesting. Can we get into that a little bit? Can we go a little bit?
And when those experiments were presented to some of the top cancer geneticists in our country, and were asked, how do you recognize these nuclear mitochondrial transfer experiments as being absolutely against the somatic mutation theory? One gentleman said, well, if that's right, then everything that we're doing in the cancer field, almost everything is wrong, and therefore those experiments cannot be right. So you tell me what's wrong with that picture.
Yeah, but that seems to predominate across all of the medical and health profession. They almost try to build something to fit their narrative. We're told that red meat causes cancer and our fat clogs our arteries and so on and so forth. Yet we know this to be untrue. You and I work in the spaces that we read these studies and we present these studies on a daily basis. But when you present it to someone within the medical community, there seems to be a mental block, almost tunnel vision, if you like, whereas they can only see what's put right in front of them, which baffles me, because as a scientist, I mean, you should work towards disproving your theory until all of these other things are taken out of the equation, and then you're left with the truth. So you should be trying to disprove your theory rather than trying to defend it. And that's what I try to do as a nutritionist. So I've studied all different types of nutrition, from veganism all the way up to carnivore. And I'm carnivore, so I live a carnivore-based lifestyle. Been ketogenic for over a decade, and it's been an incremental change for me, these slow incremental gravitational changes towards reducing carbohydrate initially. I became low carb, then I gravitated into what I'd call a dirty keto lifestyle, then a clean keto lifestyle. And you learn to understand how damaging some of these compounds are. Some of them from the foods themselves, some of them through the toxic chemicals that have been added to these compounds in their manufacturing process, which we can get into as well if you like. But it's led me down this path of becoming strict ketogenic, and now for the last 4 to 5 years, I live a carnivore-based lifestyle. But you mentioned there in regards to Paleolithic man and how their lifespan was a lot smaller. And this is an argument that I get thrown to me quite often is, well, they didn't live that long back in them days. But if we look at the average lifespan past the age of infancy, then these ages are 70 to 80 years of age without central heating, without medication, without antibiotics. For me, that's proof positive that an ancestral appropriate lifestyle, living a ketogenic lifestyle, can allow us not just to survive, but thrive. But we still live in an age where everything is genetic, and it's
just it's the power to be, the power structure that you're dealing with. Think about it for a minute. You're dealing with your federal government. In your case, it's the NHS, I guess, and in our case, it's the National Institutes of Health, where they all clearly state that this is a genetic disease. Cancer is, according to them, 100 different or more diseases, very complicated, all genetically different. So you have that, and the power of the hospital systems, the pharmaceutical systems. It's the power structure that is resistant to this. Like you just said, when you transitioned yourself from to this low carbohydrate ketogenic lifestyle, it didn't happen overnight. You transitioned yourself over time to realize what worked best for you. It will take time for the industries, the cancer industries, to readjust their thinking. It can't happen overnight. You can't cause such a catastrophic change in an already well-oiled system working according to the training that all of these folks get in medical school and in textbooks and in college, and then all of a sudden make this revelation that, oh, we've got to change everything. You have to do it gradually, just like you did. You have to, the systems must change. And we don't want to throw out all of the toxic things that we're using to manage cancer. We just have to reduce them to some extent, make them a little bit less frequent and a little bit less in dosage, while your body is in a state of nutritional ketosis. And then you'll find that these things work even better. Many of these toxic chemicals that are poisonous actually become less poisonous and more therapeutic when you use them in lower dosage and less frequently. So we don't have to throw out everything. We just have to know how to use what we have better in light of the effect that transitioning the person, like what we recommend in our writings, is that a person who comes into the clinic, oftentimes they have obesity, they have type 2 diabetes, hypertension, high blood pressure. You have to slowly move that person from a state of unhealth to health, gradually by restricting carbohydrates, more exercise. And then when they get into this better zone, then we can we use drugs to go after the glutamine problem, because the tumor cells can't live without glucose and glutamine, and we have to do it strategically. So again, it's transitioning like you did. We transition the cancer patients slowly, depending on the individual, their age, their gender, their cultural background. I mean, all of these things play an important role in moving a person into a state of nutritional ketosis. And what we did here at Boston College, we developed the glucose ketone index calculator, which you can then, it's a quantitative measure to know whether or not you're really in nutritional ketosis. So people say, oh, I eat this, I eat that. How do you know well, I don't know, I'm just guessing. Well, with the glucose meter, with the Keto Mojo meter, you can quantitatively know whether or not you're in nutritional ketosis. And when the patients are in that zone of 2.0 or below, where the ratio of glucose to ketones are almost unity, then the drugs can hammer these tumors out of existence with low levels of these drugs, different sequence, unbelievable. People get more and more healthy the longer they're being treated for their cancer, not just the opposite. What you see, it's unbelievable.
Yeah, which is incredible. I think I've heard you mention previously that the use of diet alongside chemotherapy treatments in regards of being ketogenic allows us to reduce the amount of chemotherapy treatment, but therefore reducing the amount of damage. But it becomes, and I may just be making this up, but I'm sure, did you say previously it's 3 to 4 times more effective living a ketogenic lifestyle?
It can be from what we're seeing on cancer patients where they can do this. They're really getting, I was talking to my colleagues in Turkey, and they were reducing the dosages because there's a certain, in order to maintain standard of care, there's a range of doses of chemotherapy that you are permitted to give patients. There's the highest dose, and then there's the lowest dose, but there's a range. And most clinics give the highest dose. But as we were putting patients into nutritional ketosis, they recognized that half or 1/3 the dose was having just, if not more, therapeutic benefit without the collateral toxicity, because the tumors are already under intense metabolic stress. So a little bit of chemical now just throws them over the edge of survival. So you don't need so much, and you don't harm the rest of the body significantly when you're doing this. A perfect example of how you modify and improve what we already have. But you've got to get the patient first into that state of nutritional ketosis. And therefore, a lot of the burden in success falls on the shoulders of the patient themselves. So this is a team effort. The patient must know that their efforts to bring their glucose down and ketones up into this nutritional state is going to be important for their eventual management of this condition and living a much longer life with a higher quality of life and a greater overall survival. But a lot of it's falling on the shoulders of the patient. No longer is the patient going to be a passive bystander in this process.
Yeah, 100%. And I think, what you've just said plays into the fact of what we know in regards to being ketogenic increases the mitochondria. It not only increases, but it makes it more efficient, which plays further into your argument that this is a mitochondrial issue. From your teachings previously, what I say to people is that cancer is caused by damage to the mitochondria, causing mitochondrial dysfunction. And I think they're probably your exact words. Correct me if I'm wrong, but the cells lose their ability for oxidative phosphorylation, so therefore they can't produce energy through the electron transport chain, and then it pushes glucose into a process of fermentation, which fuels the cancer. I mean, is that right so far?
Well, that's predominantly what we know from the work of Otto Warburg, the great German scientist from the 20th century. He clearly knew what caused cancer. What the problem with Warburg, he didn't know how to capitalize and use the knowledge that he had to develop a therapy, which we did. However, there was a lot of misunderstanding by Warburg and others at that time about how much energy you get from oxygen that you breathe, and how much energy you might get from glycolysis in the cytoplasm. So they were doing Warburg was driven by the quantity. He was in a cell of scientists that were rigidly quantitative in everything they did, which was very important. However, when you become too quantitative, you lose sometimes other explanations. Like, for example, Otto Warburg said that 1 mole of oxygen consumed was equivalent to 7 moles of ATP produced through oxidative phosphorylation. And he got those numbers from Hans Krebs, who worked in Otto Warburg's lab. And of course, the Krebs cycle, and these guys are all Nobel Prize recipients. So that's true for normal tissue. 1 mole of oxygen produces about 7 moles of ATP. That's not true for the cancer cell. The cancer cell takes in oxygen, but produces radical reactive oxygen species, which are carcinogenic and mutagenic. So the mutations in the nucleus are coming from the damage to the oxidative phosphorylation. But the mitochondria in cancer cells can produce some small amount of energy through oxidative phosphorylation, but it's insufficient by itself. And what happens is the cell gradually upregulates fermentation, taking in more fermentable fuels and so it doesn't happen overnight. Like Warburg said, if you damage OXPHOS too acutely, the cell dies and you'll never get a tumor from it. You have to have cells that are capable of transitioning over time from OXPHOS to what we call energy without oxygen, which is fermentation. And the waste product, lactic acid, is an indicator of energy through lactic acid fermentation. And that goes way up in cancer cells. However, what Warburg and the field still does not, Warburg never knew, and the new field, the current field still has difficulty understanding. We, working with Christos Xenopoulos from Semmelweis University, have identified a second fermentation pathway in cancer cells, which is a glutamine fermentation. This is really interesting because the mitochondria itself, incapable of producing sufficient energy through oxidative phosphorylation, can produce energy in the mitochondria by fermenting glutamine in the glutaminolysis pathway. This is incredible. So all the field thought that the tumor mitochondria were respiring glutamine, but we have shown it's not being respired, it's being fermented, and the waste product is succinic acid. So the waste product of cytoplasmic glycolysis, aerobic glycolysis, is lactic acid, and the waste product of mitochondrial substrate level phosphorylation is succinic acid. And these cancer cells are throwing these two molecules out, clearly telling us, I am fermenting glucose and glutamine. If you want to kill me, you must take away these fermentable fuels. I am telling you that. Why are you too stupid to not know that? The cell is telling us exactly what they're doing. And we're not looking at that. We said, that's the way you kill them. And then you transition them over to fatty acids and ketones. They can't use fatty acids and ketone bodies because you need a good OXPHOS system to do that. And they store giant amounts of lipids in the cytoplasm because they can't burn them. So to protect the cell from damage, they store. So all major cancers are storing fatty acids in the cytoplasm, a marker to tell us that they can't respire effectively. These cells have been telling us in no uncertain terms for decades what they're doing to stay alive. And we have ignored the very signals that the cells are telling us. But I see what they're telling me, and I know how to kill them. But nobody else wants to know about it.
Yeah, that seems to be very much the case. So look, in simple terms, Professor Seyfried, are we saying that cancer cells, there's two fuels? So currently we've got glucose as a fuel and glutamine as another fuel. So let's look at glucose first of all. Glucose comes from carbohydrate. We can get it from a number of sources of foods that we consume. But would you say that glucose is the number one fuel source? Let's remove glutamine currently, but glucose being the number one fuel source, which we predominate within our diet. So is it?
Well, don't forget, even when you're in a Paleolithic ketogenic diet, you still have glucose.
Yes.
Don't forget the glucose produces through the 10-step Embden-Meyerhoff-Parnes pathway pyruvate, a 3-carbon molecule. That goes into the mitochondria and is completely oxidized, and the waste products of that are CO2 and water. The problem is if your mitochondria aren't effective or you're in a hypoxic environment, that's fermented to lactic acid. So you can't. So it's being diverted down a bypass pathway to get energy. But you have to have a tremendous amount of fuel to make up the lost energy from oxidative phosphorylation. That's why large amounts of glucose are needed for cancer growth, not only for the energy, but also for producing metabolites so you can synthesize new DNA, RNA, and protein and lipids. So you have to have metabolite synthesis, the machine. This is a growing machine, this cancer cell. So you need two things. You need the energy and you need fuel for growth. And the carbon source from glucose gives us we can build lipids and we can build protein and we can build a part of the nucleic acid, but we need nitrogen. Where's the nitrogen coming from? It's coming from glutamine. It has 2 nitrogens in it, and that can produce DNA and RNA, help them with the proteins, and give us energy through mitochondrial substrate level phosphorylation. So clearly, these 2 fuels do everything that the cell needs to survive. And we have gone through and interrogated these cancer cells to see what else can they use in replace of glucose and glutamine. We can't find it. They can use a little bit of this and a little bit of that. The problem is there's not much of this or that in the microenvironment. In order to drive the beast, you need sufficient logistical supply of the fuels to drive all this and the metabolites. And glucose and glutamine are abundant in the cancer microenvironment. So it's going to have plenty of energy. If you don't take away that energy, it's extremely difficult to kill. And radiation and chemo, all that acidification around the tumor is coming from the fermentation of these two fuels, blocking these therapies to try to kill the cancer. Everybody's going nuts. Oh, the cancer cells are so resistant. They're so tough. Yeah, because you're feeding them two fuels that they need to grow. Take the fuels away, you see how weak they become.
Yeah, and a few things there. I mean, there's so much information with this that I think we could probably speak about this for hours, but you mentioned pyruvate through glycolysis, which is something that we don't create through beta oxidation or ketone production. When it comes to glucose, yes, it's in our diet. It's found in many foods that we consume. Structurally, if we look at every cell, the average mammalian cell, I think polysaccharides make up about 2% of the cell. 70% is water, and then around 18% is protein, 5% is lipid. So to think that if we were to consume or predominate carbohydrate as our main contributor for nutrition and energy, then this goes against what our bodies are made of. So from a structural perspective of every cell within the body, we're told that proteins and fats make up every cell. Yes, we consume glucose through our evolutionary period, but this would have been in small amounts, a little bit found in organ meats, very little found in muscle. And again, any glucose would have been seasonal and would have come in the form of things like fructose. Now, the interesting thing with fructose is that also ferments, or has the ability to ferment, doesn't it?
Well, fructose is converted back into glucose in the body too. So, but it goes through a couple of other pathways. It's hazardous in large amounts. It's a little bit in fruits. You can get fructose sugar from fruits, but when you pump high fructose into all these sweet Coca-Colas and Pepsi-Colas and Diet Pepsi, or not even diet, all these other kinds of sugars, a lot of it has high fructose corn syrup in it. This is not good. But the issue here is we have to focus in my world. I have to focus on killing cancer cells without toxicity to the rest of the body. You have to know how to wield the power of nutrition to keep the rest of the body healthy, but you also need to know how to strategically target and restrict the two fuels driving the dysregulated cell growth. So you have to know that we have to be very careful in targeting glutamine because our gut requires glutamine. We want a healthy microbiome. We want a healthy gut. We don't want to destroy that. And we have to be very cautious about that because glutamine is a fuel for our healthy gut. Glutamine is also a fuel for our immune system. So if we're too aggressive in targeting glutamine, we can harm our immune system, which is needed to prevent infections and to pick up the dead cancer cells, the corpses. So that's why we developed the press pulse therapeutic strategy, where we can choke off glucose significantly with diet and exercise. Exercise, unbelievable. So diet and exercise can really choke off the glucose. But then we have to come in with drugs to strategically challenge the glutamine pathway. And that's where we are right now. Dosage, timing, and scheduling to maximize how we're going to achieve this resolution of cancer without harming the body. And you need to know how to play one group of cells off of another in your own body. So when you do exercise, muscle stores glycogen because a muscle does not share glucose. So if we have glucose in our blood and we're exercising, the muscle takes it and does not share it. And if whatever little you have is going to go to your brain, the tumor is going to be low on the totem pole to get that glucose when our normal systems are going to be using it. So they get marginalized. So yeah, man, it's easy to kill these damn tumor cells if you know what to do, and can do it without toxicity. Problem is nobody knows what I'm talking about.
But I mean, the way that you describe it there seems you make it sound incredibly simple. Stop consuming the compounds that are feeding the cancer cells. It just seems super straightforward.
Well, wait, we can't target glutamine is in meat, right? So, but the levels are so low. The amount that the tumor needs, eating meat, a carnivore diet, yes, there's glutamine in there, But glutamine is already super high in our body anyway. So eating some meat is not going to make it any worse. So you need a drug to take care of the glutamine issue. Go and eat the meat; it's not going to harm you. In fact, it's good for you. But you just got to make sure we do these cancer patients. We look at incredible numbers of blood metabolites. We look at triglycerides. We look at HDL, LDL. We look at all the vitamins. We look for power. We look for everything. And when we're bringing them into the new state, we have to maintain what we call systemic metabolic homeostasis. When you're moving. And besides, it's not easy. You take a person who's addicted to sugar, and it's like pulling them off, cocaine or nicotine. So I don't want to make this out to say, oh, this guy knows what he. Look how simple it is. Yeah, you try it and see what happens. You'll find that it's not that simple. But it's all willpower, and it's also slowly transitioning and understanding what you're doing and why you're doing what you're doing.
Yeah, for sure, for sure. You mentioned there, glutamine it's essential. And we need it. It's found in the foods that we eat, but it predominates in the body. So how can we combat the glutamine? You've mentioned previously about the DONs. Is that something that you implement? Is that still? Yeah.
It's an unbelievable tragedy that we don't have that as the number one drug on the cancer armamentarium. You have doxorubicin, cisplatin. You get all these horrible, toxic, brutal drugs that are readily available for a high price. But the most powerful drug is sitting there doing nothing, and it should be available to everybody. It's 6-deoxynorleucine. It looks very similar to glutamine. It looks like glutamine itself, but it binds it gums up the glutamine metabolism system. But if you use it in too high of a concentration for too long, you can get sick from it. So that's what happened when it was used against little kids with leukemia. They were doing well, but it was causing a little bit more toxicity than would have been expected. And it didn't work in some cancers. Well, they weren't targeting the glucose at the same time, man. You got to do the right way to do this. If you do it the right way, this becomes a powerful drug, this DON. Okay, and we tested others, glutamine inhibitors, but so far DON is the most powerful, 6-deoxynorleucine. But people can't get it. Now, if I were to have cancer, I have access to DON. Okay, I can get it. It says not for human use. Give me a break. I'd use it if my life depended on it. Give me a break. I give it to the goddamn mice all the time. So they're fine. So the issue here is that I know what to do if I had to do it, but I feel bad for so many people who don't have access. And then when they go to their oncologist, they never heard of this stuff. They never heard of anything that I just told you is completely never heard of any of this stuff. No evidence to support what I'm saying. Yeah, well, why don't you look at the science and why don't you look at the survival of the people who are doing this? Brad and Maggie Jones are doing the Cancer Revolution documentary, and they're collecting all these stage 4 terminal cancer patients who have done metabolic therapy and they're still alive and they seem to be in a pretty good state of health. Are they cured? Who knows? But they're alive longer than they would have been expected to be. And that's the most important thing. Management without toxicity. How long can you live? We have no clue. If you die at 98 years old and you had cancer when you were 35, you obviously were cured. But who would know that? So I look for long-term. We're looking for qualitative management, quality and management. And that's what that's our level of success.
Yeah, I agree. And I think that word keyword is thrown around an awful lot. I think it's, I tend to feel that nothing is cured. It's just in a state of remission or management because it's environmental. If, being an type 2 diabetic, if I were to go back consuming lots of these toxic compounds that I used to consume with lots of sugar and vegetable oil, seed oils, high in linoleic acid, which I believe leads to more insulin resistance than glucose does, by the way. But if I went back to consuming these compounds, then I would develop type 2 diabetes again. And I believe, from what you were saying, that it's the same with cancer cells. If we restrict the amount of glucose we consume, then we can starve cancer cells. If we put the glucose back in, then we begin to feed that cancer cell again. So it's very much environmental, but I would argue that nothing is cured per se, but it is very much an environmental issue.
Yeah, you're right. And if you can conceive in our minds what it would have been like if we were to go back 100,000 or 200,000 years ago and visit a tribe of our Paleolithic ancestors who would have never had type 2 diabetes or any of these chronic diseases, because their diet and nutrition are simply not linking to that. But if you gave those guys a big box of jelly-filled donuts, they would kill themselves for it. And then you would tell them, this might give you type 2 diabetes while they're chowing down on the donut. You think they would care? I don't think they would care at all. That's modern man.
But yeah, it is. And you've hit the nail on the head, because many of the clients that I work with come to me because they're sick. And I made the change to my diet because I was unwell. Had I not felt unwell or developed the conditions that I developed, then maybe I would have never have looked outside the box and begin my journey down this rabbit hole. And now I feel that I'm so deep down the rabbit hole that I've come out the other end. And I'm a big believer in everything that you've just said in regards to diet and nutrition. I think this is, this is the basis for everything. I think drugs are fantastic. I'm not against medication, but I believe medication should be used in a situation to help fight a problem. But we need to look at the root cause. So it's all well and good consuming medication if we have inflammation, for example, like an anti-inflammatory, but what's causing that inflammation? What's causing that insulin resistance? What's causing the cancer? You've mentioned there, so we've gone on to the premise that this isn't genetic. So it's not that we're born with cancer per se. And we know that it's mitochondrial dysfunction. So
yeah, well, let me say something. People know that there are inherited factors that can predispose you to have a greater risk of getting cancer. They are called secondary risk factors, not primary risk factors. We've looked at all of the genetic syndromes that lead to a susceptibility to cancer, Li-Fraumeni, Lynch syndromes, retinoblastoma, all of these up and down. And none of them are 100% penetrant. And every one that does develop cancer is a fermenter. The cells are fermenting. So what these inherited risk factors do is interrupt oxidative phosphorylation, leading to secondary protracted fermentation and dysregulated cell growth. It's the mitochondria that regulates the growth of the cell. So when that organelle becomes corrupted, the cell falls back on its default state, which is proliferation driven by a fermentation metabolism. So we went through and looked at all causes of cancer, oncogenic viruses, carcinogens, age, inflammation, intermittent hypoxia. We went through them all, and every one of these risk factors, whether it's an inherited factor or an acquired factor or an exposed factor, every one of them causes chronic damage to oxidative phosphorylation coupled to compensatory fermentation. Only cells that can do that are able to become cancer. So we rarely, if ever, find cancer in cardiac myocytes or neurons of the brain. Mainly because if you interrupt their oxidative phosphorylation, they die and can never become a tumor cell. So and red blood cells, of course, they have no nucleus or mitochondria. So we know it's clear. The body is telling us why certain cells can get cancer and why certain cells can't get cancer, regardless of how abusive you are. And we know because it's the two-step process: chronic disruption of oxidative phosphorylation coupled to a protracted elevation of substrate level phosphorylation, where the oncogenes turn on. They are facilitators of bringing in the fuels into the cell. They open up the floodgates so they can get high amounts of glucose and glutamine. And when you put new mitochondria in there, the oncogenes turn off and everything comes back to normal. That's unbelievable. So we have this thing all pegged out. We know what to do to prevent cancer. We know what to do to manage cancer. The problem is everybody thinks it's a genetic disease, so everything I just said is meaningless.
Yeah, which is incredibly frustrating. I mean, it's okay. So we carry some of these genes which may leave us predispositioned. So this effect on the mitochondria, does that influence things at an epigenetic level?
Because the mitochondria are the most powerful epigenetic system in the cell. So when they are suffering, they immediately release signals from the mitochondria that go right into the nucleus, and the nucleus then turns on oncogenes, which are facilitators of the fermentation metabolism. So that's an epigenetic powerful system. The cell is sensing I'm failing in my energy. Now, what you have to realize is that where most of the energy, interestingly enough, in a cell comes from the membrane pumps. These are sodium potassium pumps. They pump we have an electrical charge across all of our membranes in our body. We pump out sodium and we bring in potassium, and that leads to an electrical charge. And that's all driven by this pump action. I call it a dumbass pump, but the pumps require 40 to 60% of the energy in a cell is going for pumps, right? So when the energy fails, the sodium rushes in, potassium rushes out, and you reach equilibrium. That's called death. You gotta have the energy to those pumps. So and you can either get the energy from oxidative phosphorylation, or you can get it from substrate level phosphorylation, which is fermentation. And the bottom line is fermentation is so less efficient than than oxidative phosphorylation. So you have to bring in, otherwise the cell's going to die. Yes, and it grows out of control. Why? Because the organelle controlling the differentiated state, the mitochondria, is corrupted. It can no longer do that. So everything is explainable. The cells fall back on a proliferation because all of our cells in the atmosphere, in our planet, 2.5 billion years ago, were all fermenters, and they grew without regulation because there was no oxygen. And they were fermenting. And the cancer cell is using those heirloomic pathways to stay alive, driven by a fermentation metabolism. So clearly, we can put all together. And people say, "Oh, it has to be genetic because my grandpa had it, my uncle." You're living in a common environment, abusing yourself using the same thing too. So we can explain almost everything associated with this phenomenon called cancer when we understand it from evolutionary biology, systems physiology, and nutritional biochemistry. So we can put it all together.
Yeah, which, I mean, I can attest completely to what you've just said in regards to what people say and what they believe in regards. It runs in my family, but as you say, you tend to eat what your parents eat, what your brothers and sisters eat. Those compounds that we consume can be incredibly detrimental. You'll know from speaking with the likes of Dr. Chafe, things that, certain plants contain toxins, but plants today are not the plants that they used to be also. They've been heavily genetically modified, sprayed with toxic chemicals like glyphosate. Glyphosate will block the shikimate pathway. That will lead to a fermentation process in the lower gut also, and leads to increased triglycerides and so on and so forth. But it's these toxic compounds that they're found in absolutely everything. They're not the foods.
No,
they're not foods. They're man-made chemicals. These compounds that have been.
Well, that's the whole thing about highly processed foods, carbohydrates. The global dissemination of foods across the planet, highly processed carbs and chemicals and all these kinds of things do impact negatively on our physiology over time. And a new Oxford dictionary term in the last few years was called locophore. A locophore is somebody who eats only vegetables and meat grown locally, all natural. So none of this. But you know how hard it is? We're sitting in traffic. We're working all day long. We're under stress, and now we got to go out in the backyard and try to get a tomato off the thing and slaughter some chicken in our backyard. We don't have time for this kind of stuff. We throw something in the microwave. It's convenient. It's easy. And next thing you know, we're obese and demented, and then you say, "What happened?" Well, the problem is. We have to recognize what these things are and try to adjust to them as best we can, because we know that chronic stress, loneliness, poor sleep, bad diet, no exercise. This is the modern Western way. This is the way most people are exposed throughout the world. And as soon as that Western way comes into some tribe, all of a sudden you get an explosion of all these chronic diseases. I visited the medical school at Thunder Bay, Canada, which services the Inuits in the northern part of Canada. And they used to be the healthiest people on the planet about 150 years ago. I mean, they were killing whales and seals and this kind of thing. Very little greenery in their diet. It was very seasonal and this kind of stuff. Mostly meat and fat and this kind. But now these poor folks, 50% of them have type 2 diabetes, dementia, cardiovascular disease. They're the sickest people on the planet. All because they started eating highly processed carbs and no exercise, and the government takes care of them. It's like, wow, what happened? You can just clearly see within 2 generations, you go from super healthy to super sick. and it's all related to the diet and lifestyle. So, so we know it, but who wants to change diet and lifestyle? So metabolic therapy can be used to both prevent cancer as well as manage cancer. And it's very different from standards of care. When you think about it, okay, we know the obesity diabetes epidemic is linked to our diet and lifestyle, puts us at risk for cancer. So we can use a ketogenic metabolic therapy to put you into a new metabolic state, keeping your mitochondria healthy. It's very difficult to get cancer if your mitochondria remain healthy. But nobody cares because we have an obesity epidemic. Obviously, these people never heard of this stuff. But if they do get cancer, then we can use a very similar kind of treatment to manage these folks. This is strikingly different than what we do today. When you have cancer, you have radiation, toxic poisons, and surgical mutilations and all kinds of stuff as a form of treatment. You don't usually do that to somebody before they have cancer. You don't see a line of people lining up in front of Dana-Farber, MD Anderson. Can you nuke and poison me so I don't get cancer? Right? No. If I have cancer, you can nuke and poison me. But before this is the crazy stuff. This is nuts. So clearly, metabolic therapy can both prevent cancer as well as treat cancer, but you do a few extra things in the treatment process. But it's all diet and lifestyle and knowing how your body uses energy. And once you know that, then you should be able to make choices. And that's up to you. I'm not saying any government should restrict carbohydrates or drinks or whatever, but people, if once they're aware of it, they can make conscious choices and then determine where they would like to go in their life.
Yeah, I agree. But I think you're right. It's also incredibly difficult. Sugar blocks the prefrontal cortex. It blocks our body's ability to make sensible decisions. And you're right, sugar is highly addictive. It's one of the most addictive drugs, on the planet. So I think, there's a divide within like the nutritional community currently in regards to some people believe that fruits and veg are incredibly beneficial. And then on the flip side, there's the ketogenic carnivore community. But in between, you've got the standard Western diet, if you like, full of processed foods. Now, we all know the processed foods are detrimental. So even at an incredibly basic level, we should be trying to make a change and trying not to consume these processed foods. We know that they're not good for us, yet we still consume them avidly because you've hit the nail on the head. They're convenient. But the most convenient food for me, at least, that exists on the planet, that is also one of the most nutrient-dense foods, is a piece of steak, a piece of beef. I mean, I chuck that into a pan. Within 2 minutes, it's the original fast food.
Yeah, I know.
It's eggs and beef.
Yeah, well, eggs and beef are far more expensive than highly processed Twinkies and all these other kinds of things that you get. But I agree with you 100%. I mean, you throw in a bunch of hamburger meat, crack a couple of eggs in there, throw in some sriracha sauce, make it a little spicy. But I'll tell you, when my students do this for a week or two, no carbs, your brain starts to say, hey, where's the sugar high? Where you're taking away the drug. People say, oh, I'm not addicted to glucose. Oh yeah, go water only fast for 3 or 4 days, see what happens. You start looking at your pet in a different way. It's really addictive. It is totally addictive.
It is 100%. And it goes deeper because when we look at things like serotonin and dopamine, these are things that we are hardwired to chase, as you mentioned earlier. And sugar blocks these pathways. And many of the compounds that we consume, like the phytic acids, the lectins, and the anti-nutrients, they block the absorption, the process of our aromatic amino acids and prevent
when
us.
When you eat fat, it triggers the hormone cholecystokinin, which is an appetite suppressant, actually. But the mice, they don't have that appetite suppressant as much as humans have. So this is a kind of an interesting thing. We always have to be careful in our preclinical studies because the mouse has a basal metabolic rate 7 times that of a human. So everything happens like in a flash. Like most humans have a heart rate of about 70 beats per minute or something like this. The mouse heart rate is 650 beats per minute.
Wow.
Our head would blow off our body if our heart went that fast. So we have to be careful when we do the translational studies from our preclinical systems to humans. And we find humans do so much better than these poor mice on these transitions. But we need to use the preclinical system to know what will be effective in the human system, because we don't want to treat anybody with something that hasn't been vetted first in a preclinical system, and then we can modify and perfect it for the human as we go forward. So this is the strategy that our group has taken over the years. We work everything out in preclinical models of the worst kinds of cancers in the natural host setting. None of these genetically engineered mice or cancers. Everything that we work with is all natural. And then we get these systems where we're seeing tremendous therapeutic benefit. And then our clinician friends start to apply this in the clinic. And yes, diet and nutrition are absolutely essential. If you're going to do ketogenic diets or any kind of a diet, pescatarian, Mediterranean, it has to be nutritionally balanced, and it has to bring the patient into a glucose ketone index of at least 2.0 or below. Then you're in a metabolic state for having your cancer cells maximally targeted and killed without toxicity. So again, but the stress is you having to get into a GKI of 2.0 or below, which for some people may not be that easy.
Yeah. Which, yeah, I mean, a few points there, and I'm conscious of the time, so I won't keep you too much longer. But I mean, you mentioned cholecystokinin there. Fats will also increase BDNF, which helps us with inhibitory control. The sun can help us with melanocyte-stimulating hormone through UVA through the eyes, and natural fats and amino acids can help block leptin. So it's it seems to be the perfect food to prevent these.
And exercise. Make sure that exercise is in there. Walk a couple, 3 miles a day. You know, make sure you're moving. Okay, with what you just said, brings your whole body into a better state of health, which isn't bad. Some of these guys go out and they feel, I got to run a marathon. I got to run 20 miles. The next thing you know, their legs are blown out, their hips are bad. Walking, just as long as do something, bike riding. It could be, you don't have to kill yourself. These guys run out there, got to lift 100 so much weights, and I got to do this. Next thing you know, they're in the hospital with something wrong. And then they can't exercise, they get fat, and the next thing you know, they're back in the problem. So yeah, I agree. Everything has to be done logically, and the older you get, you can't go out and do all this crazy stuff. You know, I work out in a gym with all these kids, guys and girls that are 18 to 22 years old. They look unbelievably healthy. And I'm there like, whoa, you know, and then I'm going to try to lift as much weights. And next thing you know, I hear something tear, you know. When I was their age, I could do a hell of a lot more than I can do now at my age. So you just have to moderate things. Do as moderation as best you can. And you have to recognize as you get older, you have to moderate more and more. You can't do what you did when you were 25 years old. So, but again, you can certainly keep your GKI down, and you can certainly look on packages to see whether this is going to be bad or good. But, you know, I'm not going to say I never eat jelly donuts or a pizza or this kind of stuff. Of course I do, but I don't do it every day.
Exactly.
I do it rarely. I do it occasionally, but not every day.
Yeah, but yeah. I agree completely. It's, you know, you can't out-train a bad diet. Being an ex-professional bodybuilder, I can attest to everything that you've just said in regards to injury. I now compete in endurance sports, so I've done a complete 180, and now I do duathlons and training for triathlons. So, and again, I don't believe that is healthy because it's an extremity. But the way that I structure my training is that I split it. Instead of doing 20 miles, for example, it'll be 2 bouts of 10 done in the same day. Or if I'm doing 16, it'll be 2 bouts or whatever. So that time and the pressure, that activation and expression of cortisol with the HPA axis is far lower, and it's much easier to sustain, and it doesn't lead to that overexpression and blocking that negative feedback loop. But there are ways that you can do it. So I'm trying to train for endurance sports in short interval trainings, in what I call split training, i.e. training twice a day, but a lot smaller. And I find that works a lot better for combating injury. But nutrition is number one. I think, you know, if you can train all you want, and if your nutrition is bad, yes, you can almost keep the piper at bay for so long, but eventually you need to pay the piper. You know, that deposit needs to be made back to the bank in the end. And that's why I believe that, you know, we are what we eat, and we need to eat what makes us. And for me, you know, looking at what makes the weight of each cell and our bones and so on and so forth, it's proteins.
Well, what you're basically doing is you're trying to delay entropy, which is the second law of thermodynamics. We all die from disorder, and that mitochondria maintain the order in our body. And as long as you can keep that organelle as healthy as possible for as long as possible, you have a chance to live longer with a higher quality of life. And that's ultimately, and also reduce the risk for chronic diseases, which would be obesity, type 2 diabetes, dementia, and cancer. So all of these things can be wrapped up. And that's why we say the glucose ketone index calculator is a powerful tool to ward off chronic diseases. But you have a tool now. Before that, we had no tool.
Exactly.
And now we have free Libre monitors that you can put onto your arm. We don't have it yet for ketones, but eventually it will be there. So you'll be on a real-time basis knowing whether or not you're in nutritional ketosis at all times. And you can eat certain things and watch the parameters change. It's unbelievable. This is going to be wonderful. People say, oh my God, let's see. I really want that jelly donut. Let me see what it does to my GKI. Oh,
exactly.
And then all it makes is, oh, I guess I'll only have a little bit more, no more.
Yeah, it's interesting.
At least it gives you a quantitative measure. Right now, it's all guesswork. But once people realize that the GKI can allow them to stay in these zones and know that their bodies are getting very healthy, at least they have some quantitative measure from a drop of blood on the tip of the finger is what it is. And you can buy the meter from Amazon. So all of this is there. It's just that people just don't have access to it yet or know about it once they know about it. And our work here is all supported by philanthropy and private foundations. We had a really large, nice grant from the British UK childhood cancer. We developed an incredible therapy for high-grade glioma in children, non-toxic, because the number one killer of kids' cancer is high-grade gliomas. It's a terrible, horrible disease. But we've actually found that if we target glucose and glutamine simultaneously while transitioning the body into nutritional ketosis, we're able to keep these high-grade gliomas at bay, keep them down, make them indolent. So these kids could live so much longer. It's going to be a blockbuster. The problem is they don't know about it. And when you tell them about it, it can't be true. It's too good to believe. It's like, well, why don't you look at the data and then you come to your own decisions about this. But the future is coming, and the future is metabolic therapy. Brace yourself. If you're not part of it, get out of the way because it's coming.
I agree completely. And do you know, just a point on that, I think you present this information to someone, you tell someone to look at this information. The issue is they will go and show the information to their doctor, which their doctor usually says that this is a load of rubbish, and people believe their doctor, and in there lies the problem. So it's breaking this cycle, I think. And I don't think it's going to happen from the top down. I think it's got to come from the bottom up, from us.
Well, that's why your shows, these YouTube things that I do, and we're starting our own YouTube video, our own channel called Talking Cancer with Professor Seyfried. And then people hit me with all kinds of questions, students and all these, and then we can address them logically. And we bring them to the literature that supports what we're finding, because we're not just making this stuff up. I mean, we have scientific evidence, tested experimental controlled experiments looking at what we're doing, and let the people make their own decisions. You're absolutely right. And that's why we publish an open access journal. So this is not behind a paywall. People can get my papers, they can read them, and if they don't understand them, they can have someone explain some of this stuff to them. And at least they feel empowered. Knowledge is power. And they'll take charge. Believe me, people want to live, and they'll do it.
Yeah, I agree. And look, it's, we have a private community, and I know there are one or two people suffering with cancer issues. It would be fantastic, and I'd be honored if we could get you in there for a live Q&A at one point, or we can direct them to your channel, or both. But I think that would be absolutely fantastic, and I've got nothing but admiration for what you were doing. Really quickly before you go, Dr. Seyfried, the supplementation of things like MCT oils, C8, caprylic acid, and exogenous ketones, is there a place for these within treatment? As
I think so. I think so, because I know Bulletproof Coffee, I've made it myself. It's really quite good. I use a couple of tablespoons of MCT oil. I use real butter, and I use natural cream, and maybe a little stevia in there. It's an artificial sweetener, but it's supposed to be not so toxic. You shake it up, it's like a latte, for crying out loud. You drink the damn thing, you don't feel hungry for the rest of the day. It's unbelievable. But you're absolutely right. I mean, I think those things have a place. Ketone supplements ketones are kind of bitter. if you take the real natural stuff like my friend Dom DiAgostino does, you ought to have him on your show. He's the Mr. Nutrition expert himself.
If you could do an intro, I would massively appreciate it.
Yeah, Dominic, he broke the world record in lifting some sort of squats and lifts at some point. The guy works out with Dwayne Johnson, the movie. He's that kind. He looks like that guy. So all these muscles. But Dom does all this stuff too. And so I think that we just need to stay on this right path, and we'll be fine.
Yeah, fantastic. I produce C8, the world's highest purity.
C8. Yeah, well, C8, caprylic acid, it produces ketones real quick. So it's good. You can spike your MCT oil with a little, because generally caprylic acid is not an MCT oil, but you can spike a little bit of that. I think it comes from goat's milk. You can get a lot of it from goat's milk, actually. Yeah, very good, but not too much, because you just want it all to go to ketone. The liver is our ketone factory. So a liver makes D-beta hydroxybutyrate, which is the ketone. You don't want L-beta hydroxybutyrate. You want D-beta hydroxy. That's the one that keeps your mitochondria healthy, and that comes from caprylic acid and MCT oils. So let your body make it naturally by doing these things. I don't know the exact dosage of caprylic, but we do put it into our ketogenic metabolic formulations. So and we wrote a paper on this with a colleague from Turkey on caprylic acid as a source of ketones naturally. So yeah, we've looked into all these things, and we're still developing. This is the future. These kinds of new diets that are going to give you the maximum bang for your buck. We're always considering cancer, but of course, dementia is another big thing that will be prevented by this too. So it's going to have a lot of utility. You got to keep your neurons and your mitochondria healthy, and all this stuff works together.
Yeah, spot on. I completely agree. I'll have to send you some. It's my C8 by certification is the world's highest purity at 99.9%. So I think even bulletproof is only like 0.1% lower. But I'll gladly send you some. So okay. Yeah, I'd love that. It's
the mice will appreciate it.
Fantastic. I love the stuff. It's I'm ketogenic, but I still use it every day.
What's your GKI? What's your GKI?
I haven't. I've been so long on my journey. I haven't tested for a long time.
Richard, please, you must count. You must first. Next time you go up, you hold up. You see, here's my GKI today while I'm talking to you.
Perfect. I will reach out to our good buddy who owns Keto Mojo. So it's Dorian Spot. Yeah. So I know Dorian. We've met at a few events. And I am looking to get his meters on board.
Well, you'll be able to look at it in real time, because you would show your GKI, chug your C8 caprylic acid, and then see how your ketones are rising in real time. I mean, what could be more informative and powerful?
I agree. Yeah. And it's interesting you mentioned that, and the Lifestyle Libra, which I've used, and it's interesting to show how much that when you exercise, how the body creates glucose. So we know that glucose is essential.
Well, it's coming. Some of it comes from the lactic acid that the muscles are throwing out. That's the core cycle. Yeah. So you can say, "Oh, why I'm doing all this exercise, my sugar's going up." That's because you're burning out. The muscles are throwing the lactic acid into the bloodstream. Yeah. And don't forget, our erythrocytes always need some low level of glucose.
They do.
They have a very low electrical -6 millivolts. The only function of erythrocyte is to move gases, CO2 and oxygen. So they don't need much of a pump. Whereas the cardiac myocyte is a -86, because that's a cell that's constantly contracting. So that cell needs a hell of a lot more energy than the erythrocyte does. So, and there's another thing, the delta G prime ATP hydrolysis, which is an incredibly important bioenergetic constant that we don't want to go into now, but it would take a whole lecture to talk about that. But all of this is all linked together for optimal performance and health.
Yeah, call for another day. But yeah, spot on. I think the erythrocytes need glucose because they don't have mitochondria, isn't it? And only mitochondria can use ketones for energy. And it's similar with the glutaminergic neurotransmitters in the brain. But as you say, that the body creates this naturally. via gluconeogenesis. So our requirement for an exogenous source is 0, but the body makes all the glucose that we need. And I think that's where the confusion comes in.
And the brain and the muscle get the first dibs on this. So the tumor, as I said, is way down on the line to get the sugar that's absolutely needed for that thing to survive.
Yeah.
So that's why you can easily transition your body and put pressure on these tumor cells.
Yeah, I agree completely. Fantastic. Dr. Seyfried, just to sum something up that I've been throwing back and forth in my head. I mean, so if we look at like gene expression, epigenetics, are we safe to say that the loss of gene expression, and we know that the loss of gene expression occurs around 10 times more frequently through transcriptional silencing via hypermethylation of the CpG islands over mutations, but are we saying that mitochondrial dysregulation enables the tumor cells to produce the building blocks, if you like, to moderate these epigenetic marks and promote that initiation of growth?
When you say epigenetics, it's methylation, acetylation, succinylation, and all these kinds of things. It's a term that people throw out that is massively complicated, and very, very few really understand when we talk about epigenetics being responsible for something. We can talk about that, but I prefer to kill all the tumor cells. After we kill all the tumor cells, make the body healthy, we can just sit down and talk about epigenetics. But the bottom line is here, without the glucose and glutamine and the inability to burn ketones and fatty acids, epigenetic, no, I don't care. Whatever you're talking about, let's kill those guys. And then we can discuss these more esoteric kinds of concepts. But I don't prefer not to waste my time talking about epigenetics. My job is to kill these things. Without those fuels, they can't survive, epigenetic or no epigenetic. So microbiome, the same thing. Let's not, when you do metabolic therapy, you got to keep your microbiome healthy. You go to get cancer treatment, you blow the hell out of your microbiome. So what are you doing? The whole thing here has to be recognized in terms of systems physiology, and that's what we work on. So yeah, I mean, I know the mitochondria, most powerful epigenetics. Oh wow, how does it do that? Yeah, it turns on oncogene. It does. I know what it's doing, and we just know how to stop it. So let's stop it and kill the cells, and not worry about those other extraneous things.
Love it. That is absolutely perfect, and probably the perfect place to end today's podcast. Professor Seyfried, an absolute pleasure to have you on. I'd love to get you on as a guest to delve deeper maybe next time, but where can people find you? How can they support you?
Well, we have two supporting systems. One is my university, Boston College. On the biology webpage, you see my picture, and there's a donation for people who would like to donate to our research. And Travis Christofferson's foundation of metabolic cancer therapies. When I send kits of information out to the cancer patients, I include those. But unfortunately, there are people that have set up channels saying they're my channels, like the charity channel. I have nothing to do with that. It says it's mine. It's not mine. There's books. I've written only one book, Cancer is a Metabolic Disease, John Wiley Press. You'll see Seyfried's books all over. I didn't write any of those books. Those books are put out by others that want to make a profit on my name. They even say I wrote the books, and I didn't write the books. It's unbelievable. I wrote only one book, Cancer is a Metabolic Disease, John Wiley Press. Yes, it's $100 or more. But these other books are like $15 saying I wrote them. I didn't write them. So this is one of the problems. But I get my money from those foundations and philanthropy to help our research go forward. And people have been very generous, and we appreciate their help. And I also, when they do support us, if you look at my papers and you look at the acknowledgement section, you say, who are all these people? Benevolent funds and this guy and that guy. Who are these people? Those are the guys that are supporting our research. So if people want to support our research and get their name in the acknowledgement section on a nice big paper that we publish, we'll put their name there and let them know that this guy has helped this paper. The information in this paper is helped by that person in the acknowledgements.
Fantastic. And I will be doing that myself. I'll put all of those links in the show notes below. But Professor Seyfried, it's been an absolute pleasure. Again, I can't thank you enough. Thank you so much. And with a bit of luck, we'll get you on again.
Yeah, thank you, Richard, for disseminating this information. You also play an extremely important role as well.
I appreciate that. Thank you.
Okay, bye now.